as we study the standard normal distribution, we also move into talking about how we can do estimates from the data that we collect, and also what the margin of error might be in the data that we collect. So first of all, this is the standard normal curve. Remember, it's listed in terms of these are the z-scores, which represent the number of standard deviations away from the mean we are. So the mean is right in the middle. This would be 1 standard deviation away, 2, then 3, and then 1 below, 2 below, 3 below, and the percentage of data that falls within that. Now, as we gather data, what we want to do is estimate what the parameters are using samples. Instead of gathering all the data and finding the parameters, which can be difficult to do, we want to do sampling and then find estimates of those parameters. So to estimate a parameter, we want to take a random sample of the population and first of all, use the statistics to estimate a parameter of the population. Remember, statistics are with the sample, they estimate the parameter which goes with the entire population, the actual value. Now, if we find larger samples, you gotta really emphasize this, the larger our sample, that usually leads to a better estimate. Now, one thing we could do is if we take multiple samples and find multiple statistics to go with it, like find the mean of multiple samples of the population, and then we average those statistics, that should lead to a better estimate of the parameter. So taking the average of multiple sample statistics should precisely estimate the parameter. After all, that is our goal, is to estimate what the parameter is, and if we can do multiple samples, find those statistics, and that leads to a better estimate, that's often a technique that is used. And when you do this, when you do multiple samples and you get statistics from that, the statistics themselves, like if you find multiple means, doing a population graph of those statistics, that's called a sampling distribution. So this is the graph, or the distribution of the sample statistics. Okay, so that's some of the background for doing estimates, some of the techniques, as well as remembering larger samples are better, and then sometimes doing multiple samples and averaging those statistics will lead to better parameter estimations. All right, now let's go ahead and talk about what our margin of error will be with these. Now, margin of error, the margin of error refers to the maximum expected difference between the sample result and the population parameter. We have the population parameter. We want to find that number, but we usually don't find the whole population and get the exact parameter. So what we'll do is we'll sample the population, get an estimate of that parameter, and so what that does is we might have some error there. That's called margin of error. We want to reduce the error as much as possible. So the margin of error is the maximum expected difference between the actual population parameter and the sample result. So between the sample result say the sample statistic result and the actual population parameter. Just a reminder that the larger our sample size, that usually gives us a better estimate. So our margin of error is going to shrink, and that's our goal. We really want to shrink the margin of error. So we want a small margin of error. Okay, now let's go ahead and come up with the formulas for this. So first of all, we're going to use, remember, a reminder that if we use sigma, that Greek letter sigma, that's the population standard deviation. That is the actual parameter. Now, when we have n, that's the sample size for it. So when we do, for instance, quantitative data, our margin of error is going to be 2 sigma, whatever our standard deviation is, over the square root of n. This is the formula we'll use for our margin of error. If it's categorical data on the other side, so this is if we have numbers as a result. If these are categories as a result, our margin of error has to do just with sample size. So we're going to have 1 over the square root of n as our margin of error for that. So this will tell us what the maximum expected difference between what we find using statistics to be the parameter, or in this case we use the statistics to estimate what it is, and the actual parameter itself. So what we've done is we've talked about what we do to get good estimates for whatever statistic we're going to use to estimate the parameter, and then also how we can calculate what the margin of error is.